Consider for a moment the ground beneath your feet. If you are sitting in a quiet room or lying in the comfort of your bed, everything around you feels perfectly still. The floor is solid and unmoving. The walls stand vertical and firm. The air in the room hangs suspended, undisturbed by any sudden breeze. If you place a glass of water on a table, the surface of the liquid remains flat and calm, mirroring the ceiling above. Our senses evolved over millions of years to help us navigate the immediate world of forests and savannas, tell us with absolute certainty that we are stationary. We feel anchored, heavy, and at rest. Yet, this sensation of stillness is perhaps the single greatest illusion that nature has ever crafted. At this very second, you are traveling faster than the fastest jet aircraft. You are a passenger on a colossal sphere of rock and iron that is rotating with a silent, relentless momentum. If you are near the equator, the ground beneath you is moving at approximately 1,600 kilometers per hour. Even at higher latitudes, in places like London or Vancouver, you are spinning at hundreds of kilometers per hour, carrying the weight of your body, your home, and the very air you breathe along with you. It is a paradox that defies intuition. How can we be rushing through the dark void of space at such tremendous velocities while feeling nothing but peace? The answer lies in the smoothness of the journey. The Earth does not stutter. It does not lurch or vibrate like a car traveling over a rough road. Its motion is ancient and perfected, a rotation so steady that it has persisted for billions of years without pause. Because the atmosphere travels with us, held tight by gravity, the air does not rush past our faces at supersonic speeds. Instead, the sky is a blanket that wraps around the planet, moving in lockstep with the ground, creating a protective bubble of calm in which life can flourish. Imagine, if you will, rising above the surface. Picture yourself drifting upward through the clouds until you reach the quiet edge of space. From this vantage point, the illusion of stillness vanishes, and the true dynamism of our world is revealed. You would see the great blue marble of Earth hanging against the velvet blackness of the cosmos, and you would see it turn. It is a majestic, slow-motion pirouette. The continents drift into the sunlight and then slip back into the shadow, a ceaseless cycle that marks the rhythm of all life. This rotation is the heartbeat of our planet. It is the engine that drives the winds and the currents, mixing the warm waters of the tropics with the cold depths of the poles. It is the force that draws the line between day and night, ensuring that no side of our world is left permanently frozen or eternally scorched. Without this spin, the Earth would be a desolate, alien place. But because it turns, we have the morning breeze, the evening tide, and the shifting constellations that have guided sailors for millennia. The physics behind why we do not feel this motion was a mystery that puzzled the greatest minds of antiquity. For centuries, scholars believed the Earth stood fixed at the center of the universe because their senses told them so. It was not until the thinkers of the Renaissance began to understand the nature of inertia that the puzzle was solved. They realized that if you are inside a moving vessel, be it a ship on a calm sea or a planet in the void, and that vessel is moving at a constant speed in a straight line or a smooth curve, you will feel as though you are standing still. Think of pouring a cup of tea while on a high-speed train. As long as the tracks are smooth and the speed is constant, the tea pours straight down into the cup, just as it would in your kitchen. The liquid behaves as if the train were motionless. even though the landscape outside is blurring past at 300 kilometers per hour. We are all pouring tea on a train that never stops, a train that is the Earth itself. We and everything around us possess the same momentum as the planet. We are not merely on the Earth, we are part of its kinetic energy. However, there are subtle signs of this rotation if one knows where to look, ghostly fingerprints left by the spin of the world. In the mid-19th century, a French physicist named Léon Foucault devised a beautiful and simple experiment to prove that the world turns beneath us. He suspended a heavy brass bob from a long wire in the Pantheon in Paris, creating a pendulum that could swing freely in any direction. If the Earth were truly stationary, that pendulum would have swung back and forth in the exact same line forever. But it did not. Over the course of the day, the floor of the Pantheon slowly twisted beneath the swinging weight. To the observers standing in the hushed hall, it looked as though the pendulum's path was rotating, knocking over small pins arranged in a circle. But the pendulum was merely keeping its course. It was the cathedral, the city of Paris, and the observers themselves who were turning. Watching a Foucault pendulum is like watching the heartbeat of the planet made visible, a hypnotic, slow-motion proof that our stillness is a lie. The rotation also sculpts the planet itself. The Earth is not a perfect sphere. The immense centrifugal force generated by its spin, the outward push you feel when you turn a corner in a car, causes the planet to bulge slightly at the waist. The equator is pushed outward by more than 20 kilometers compared to the poles. If you were to stand at sea level on the equator, you would be farther from the Earth's center than if you stood at the North Pole. This slight flattening is a testament to the fluidity of rock and water over geological time, yielding to the persistent command of the spin. This motion also bends the winds. Imagine trying to draw a straight line on a spinning sheet of paper. Your pen would create a curve. The same happens to the air rushing toward the equator. The Earth spins beneath the wind, causing it to deflect, to the right in the northern hemisphere and to the left in the southern hemisphere. This phenomenon, known as the Coriolis effect, creates the great spiral patterns of hurricanes and the reliable trade winds that allowed ancient civilizations to cross the oceans. The spin of the Earth is written into the very weather that brushes against your cheek, but the rotation of our planet is only the first layer of motion. If we pull our perspective back further, widening our view to encompass the entire solar system, we discover that the Earth is not just spinning, it is racing. We are orbiting the Sun at a velocity of roughly 107,000 kilometers per hour. This is a speed so incomprehensible that it strips away any conventional sense of fast or slow. At this speed, you could travel from New York to London in a mere handful of minutes. And yet, we do not feel this rush. We do not feel the wind of the cosmos because space is a near-perfect vacuum. There is no air to resist our passage, no friction to grind against the hull of our planetary ship. We glide through the void in perfect silence, following a gravitational groove carved by the sun. It is a free-fall that never ends, a constant surrender to the curvature of space-time. Even the sun itself is not standing still. Our entire solar system is merely a speck in the vast, turning disk of the Milky Way galaxy. The sun, dragging the Earth and all the other planets with it, is cruising through the interstellar arm of Orion at nearly 800,000 kilometers per hour. We are circling the supermassive black hole at the galaxy's heart, completing one grand revolution every 230 million years. This means that the last time the Earth was in this specific part of the galaxy, dinosaurs were just beginning to rise and the flowers had not yet evolved to bloom. When we consider these layers of motion, the spin of the Earth, the orbit around the Sun, the drift of the galaxy, we realize that we are executing a complex, spiraling dance through the universe. We never return to the exact same place in space. Every second of your life, you are occupying a coordinate in the cosmos that you have never visited before and will never visit again. We are travelers on a corkscrew path, drilling through the darkness of infinity. Why does this realization not terrify us? Why does the knowledge of such precipitous speed not induce a sense of vertigo? Perhaps it is because the motion is so grand, so consistent, that it translates into a form of stability. There is a reliability in the spin. We trust that the sun will rise tomorrow because we trust the earth will continue to turn. We trust that winter will turn to spring because we trust the orbit will hold true. The motion is not chaotic, it is rhythmic. It is a cosmic lullaby that rocks us to sleep, a cycle of light and dark that governs the chemistry of our bodies and the patterns of our rest. Consider the line that divides day from night, the terminator. It is a soft band of twilight, thousands of kilometers long, constantly sweeping across the surface of the globe. At this moment, somewhere on Earth, the sun is dipping below the horizon, painting the clouds in shades of violet and burnt orange. Birds are finding their roosts, and the noises of the day are softening into the hum of the evening. At the same time, on the opposite side of the world, the sky is brightening. The first golden rays are touching the tops of mountains, waking the forests and the cities. This eternal transition, this ceaseless dawn and unending dusk, is only possible because we are spinning. If the earth were to stop, one half of the world would bake in endless noon, while the other froze in eternal midnight. Life, as we know it, clings to the balance provided by the rotation. We need the cycle. We need the activity of the light and the restoration of the dark. Our biology is tuned to the frequency of the planet's rotation. We are creatures of the spin, synced to the 24-hour rhythm of our turning home. As you lie there, feeling the heaviness of your body against the mattress, try to extend your awareness downward, through the floor, into the soil and the bedrock. Imagine the sheer mass of the planet beneath you. It is carrying you eastward, always eastward, rolling toward the rising sun. You are not stationary. You are an astronaut on the most magnificent vessel ever built, protected by a thin layer of atmosphere, warmed by a distant star, and held in place by the gentle hand of gravity. The stillness you feel is a gift. It is the result of forces so perfectly balanced that they cancel each other out, leaving you with a sense of peace. It allows you to pour your coffee without spilling, to build houses of cards, to sleep without holding on. It is a stillness born of momentum, a tranquility that exists within the eye of a cosmic storm. But this brings us to a deeper, more fundamental question. We know now that we are moving. We know that the Earth spins, the sun orbits, and the galaxy turns. But why? Why is the universe not static? Why did the cosmos not settle into a motionless arrangement of stars and dust? Where did this tremendous energy come from? To answer this, we cannot simply look at the sky as it is today. We must close our eyes to the present moment and let our minds drift back through the eons. We must return to a time before the earth existed, before the sun ignited, before the planets were anything more than scattered dust in the cold dark. We must go back to the beginning of the dance. Everything that spins today, from the smallest asteroid to the largest galaxy, is carrying a fossilized memory of a motion that began billions of years ago. The rotation of the Earth is not a new invention. It is an inheritance. It is a legacy passed down from a great ancient cloud that collapsed in the deep past. To understand why you are spinning tonight, we must witness the birth of the solar system itself. We must watch as the silent, floating dust begins to fall, and as the fall begins to twist. Let us drift back now, rewinding the clock of the universe, past the age of the dinosaurs, past the first bloom of microscopic life in the primordial oceans, and past the cooling of the Earth's crust. We travel back 4.5 billion years into the deep velvet silence that existed before our home began to turn. Here, in this ancient epoch, there is no Earth, there is no sun, there is no moon to pull the tides, for there are no oceans to be pulled. There is only a vast cold cloud of gas and dust floating in the interstellar void. Astronomers call this a molecular cloud or a stellar nursery. It is a structure of immense, ghostly beauty, stretching for light years across the darkness, composed mostly of hydrogen and helium, dusted with the carbon and silicon remains of stars that lived and died long before. To the naked eye, this cloud would appear motionless, a frozen sculpture of smoke hanging in the blackness. It is incredibly cold, only a few degrees above absolute zero, a place where atoms move with lethargic slowness. Yet, even here, in this seeming stillness, the seeds of rotation are present. The cloud is not perfectly uniform. It is rippled with the faintest currents, disturbed by the gravity of passing stars or the distant shock waves of supernovae exploding in the galaxy's spiral arms. These subtle movements create a tiny, almost imperceptible net rotation. The cloud is slowly, lazily twisting, like a leaf caught in the gentle eddy of a dark river. Then something shifts. Perhaps a shock wave strikes, or perhaps the cloud simply becomes too heavy for its own internal pressure to support. Gravity, the patient sculptor of the cosmos, takes hold. The cloud begins to collapse inward. This is the moment where the destiny of our world is written. As the vast cathedral of gas falls in upon itself, shrinking from a width of light years down to the size of a solar system, a fundamental law of physics awakens, the conservation of angular momentum. It is a rule as absolute as gravity itself. It dictates that as a spinning object shrinks, it must spin faster. We see this principle in the grace of a figure skater on a sheet of ice. When she begins her spin with her arms outstretched, she rotates slowly, drifting through the turn. But the moment she pulls her arms in tight against her chest, her speed increases dramatically. She becomes a blur of motion, spinning faster and faster until she finally opens her arms again to slow down. She has not added any new energy to her spin. She has simply concentrated the energy she already possessed into a smaller space. The solar nebula behaves exactly like that skater. As gravity pulls the gas and dust toward the center, the cloud's lazy, drifting rotation accelerates. What was once a movement, taking millions of years to complete one turn, becomes a rapid, violent swirl. The chaotic, billowing shape of the cloud begins to smooth out. The centrifugal force, the outward pull of the spin, fights against the inward pull of gravity. This battle between falling in and flinging out transforms the cloud. It flattens. The gas that falls in from the top and bottom meets little resistance, crashing down toward the equatorial plane. But the gas spinning around the middle is held up by its own speed. The result is that the spherical cloud collapses into a magnificent glowing disk. It becomes a whirlpool of fire and dust, a cosmic pizza dough spun out by the hands of gravity. In the center of this spinning disk, the pressure grows unimaginable. The material is packed so tightly that temperatures begin to soar. The friction of gas rubbing against gas releases torrential amounts of heat. The heart of the cloud begins to glow, a dull red ember in the darkness. This is the protostar, the infant sun, gathering mass, feeding on the dusty banquet swirling around it. It is not yet a true star. It has not yet ignited the nuclear fires of fusion, but it is the anchor, the heavy hub around which everything else dances. Surrounding this glowing core, the disk is a chaotic, violent place. It is a racetrack of debris. In the cooler outer regions, bits of dust, coated in ice and organic molecules, begin to stick together. They collide gently at first, held together by electrostatic forces, the same static cling that makes dust bunnies form under a bed. These tiny clumps grow into pebbles, the pebbles into boulders, and the boulders into mountains. As these mountain-sized rocks orbit the young sun, they plow through the disk, sweeping up more material, growing larger with every orbit. They are the planetesimals, the ancestors of the worlds we know today. They are spinning as they form, inheriting the rotation of the disk from which they were born. When a massive rock slams into another, the energy of the collision imparts a spin to the growing body, tilting it, twisting it, setting its daily rhythm. This is why the solar system today looks the way it does. It is why all the major planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, orbit the Sun in the same direction, counterclockwise if viewed from above the Sun's north pole. It is why they all travel on roughly the same flat plane, like marbles rolling on a tabletop. They are all following the ghost of that original disk. The flat, spinning geometry of the solar system is a fossil record of the cloud's collapse. We are all moving with the current of that ancient whirlpool. Imagine standing on the surface of one of these forming worlds, perhaps the proto-Earth. It is a molten, hellish landscape, bombarded by meteors, glowing with the heat of impacts. The sky above is filled with the thick dust of the nebula, blotting out the stars. But through the haze, you would see the glowing band of the disk, a river of light arching across the heavens, and you would feel the spin. The young Earth spun much faster then, completing a day in perhaps only 6 hours. The sun would rise and set with dizzying speed, a strobe light on a chaotic world. Over hundreds of millions of years the chaos settles. The infant sun, reaching a critical temperature and pressure, ignites. Nuclear fusion begins in its core. A sudden, explosive wind, the solar wind, erupts from the star, blasting outward through the system. This wind acts like a cosmic broom, sweeping away the remaining wisps of light, gas, and dust. The veil is lifted. The nebula is gone. What remains is a clean, orderly system. The survivors of the chaotic collisions have become the planets. They have cleared their lanes, absorbing or flinging away the debris. They settle into their stable orbits, a clockwork mechanism built on the principles of gravity and momentum. The conservation of angular momentum has finished its masterpiece. It has taken a shapeless, drifting cloud and forged it into a precision instrument of circles and ellipses. But the story of rotation does not end with the planets simply orbiting the sun. The conservation of angular momentum works on every scale, fractal in its nature. Just as the cloud collapsed to form the sun and planets, smaller disks formed around the gas giants. Jupiter and Saturn, massive enough to have their own gravity wells, pulled in their own subnebulas. These miniature disks spun and collapsed to form the diverse families of moons that orbit the giant planets today. Look at the moons of Jupiter: Io, Europa, Ganymede, Callisto. They orbit Jupiter's equator in a flat plane, moving in the same direction as Jupiter's spin. They are a solar system in miniature, a repetition of the same cosmic law. They are the echoes of the echo, spinning because the gas they came from was spinning, turning because the universe remembers the motion of the past. Even the rings of Saturn are a visual hymn to this principle. Those majestic bands of ice and rock are incredibly thin, sometimes only 10 meters thick, yet they stretch for hundreds of thousands of kilometers. Why are they so flat? Because of the spin. Collisions between the icy particles dampen any up and down motion, while the rotation keeps them spread out in a perfect disk. The rings are a laboratory of angular momentum, a frozen splash of water in the void, held in shape by the speed of their dance. And what of us? What of the matter that makes up your body? The carbon in your cells, the oxygen in your lungs, the iron in your blood? All of it was once floating in that nebula. All of it was part of that great collapse. The atoms that form your hand tonight were once drifting in the cold outer reaches of the cloud, then pulled inward, spinning faster and faster, heated in the disk, locked into the rock of the earth, and eventually cycled into life. You are not merely an observer of this rotation, you are made of it. The kinetic energy of that ancient cloud is not gone. It is stored in the orbit of the earth, in the spin of the planet, in the very stability of the ground you rest upon. If the cloud had not spun, it would have collapsed directly into a single, lonely star. There would have been no disk, there would have been no planets, there would be no Earth, and there would be no you to wonder about it. The rotation is the reason for our existence. It prevented the matter of the solar system from being devoured by the sun. It held the dust at a safe distance, allowing it to cool and clump and evolve. The centrifugal force is the guardian of the planets, the invisible wall that keeps us from falling into the fire. As we visualize this process, the majestic slow-motion implosion of a nebula, turning into a blazing star and a family of worlds, we must recognize that this is not a unique event. It is happening right now in the Sword of Orion, in the Eagle Nebula, in thousands of dark clouds across the galaxy. At this very moment, somewhere in the night sky, a new cloud is beginning to fall. A new disk is flattening out. New planets are aggregating out of the dust, inheriting a new spin that will last for billions of years. The universe is a machine for turning stillness into motion. It takes the cold, potential energy of gravity and converts it into the kinetic energy of spin. It is a process of unfolding, a way for the cosmos to structure itself against the chaos. Consider the solitary beauty of a planet forming in the dark. It gathers mass, and with every asteroid it swallows, it adjusts its spin. It wobbles, it tilts, and then it stabilizes. It finds its rhythm. This rhythm becomes the day. The day becomes the unit of time for whatever life might arise there. The spin dictates the climate, the weather, the magnetic field. It dictates whether the planet will be a barren rock or a cradle for biology. Our own Earth's spin has been changing over time, sculpted by the moon and the tides, but its origin remains the same. We are turning because the nebula turned. We are the legacy of a 4-billion-year-old momentum. There is a profound comfort in this continuity. When you feel the stillness of the night, remember the storm of fire and dust from which this peace was born. Remember that the stability of your bed is maintained by a flight through space at tremendous speeds, a flight that has never faltered since the birth of the sun. We have traveled from the surface of our spinning world back to the fiery whirlpool of its creation. We have seen how gravity and momentum worked in tandem to build the clockwork of the solar system. But our sun is just one star among billions. Our solar system is a tiny raft in a much larger, darker ocean. If we look outward, past the heliosphere, past the realm of the planets, we see the grandest structures of all. We see the galaxies. These island universes, composed of hundreds of billions of stars, are also spinning. They are vast pinwheels of light turning in the void. But here, the story of rotation takes a mysterious turn. When astronomers looked at how galaxies spin, they found something that defied the laws of physics as we understood them. They found that the galaxies were spinning too fast. By all rights, they should have flown apart billions of years ago. What is holding them together? What invisible hand grips the stars and prevents them from being flung into the deep intergalactic night? To answer this, we must leave the warm light of our sun behind and venture into the cold, vast spaces between the stars. We must confront the mystery of the invisible scaffold. Drifting outward from the warmth of our solar system, we leave the familiar orbits of the planets behind. We pass through the icy sphere of comets that encircles our home like a shell, and we enter the true abyss, interstellar space. Here, the sun is just another star, a bright point of light indistinguishable from the thousands of others scattered against the black canvas. We are now in the realm of the Milky Way, our galactic home. From a distance, the Milky Way is a breathtaking spectacle. It is a vast, shimmering spiral, a disk of light 100,000 light-years across. It is composed of dust, gas, and perhaps 400 billion stars, all bound together in a gravitational embrace. And like the Earth, like the solar nebula, this colossal structure is turning. It rotates with a majestic, silent grace, a cosmic pinwheel turning in the dark. But there is a mystery hidden in this rotation, a puzzle that troubled astronomers for decades, and eventually forced us to rewrite our understanding of the universe. In the 20th century, when scientists first began to measure the speeds at which galaxies rotate, they expected to see a pattern similar to what we observe in our own solar system. In our system, the planets closest to the Sun, Mercury and Venus, move the fastest, whipped around by the intense gravity of the star. As you move outward to Mars, Jupiter, and Neptune, the orbital speeds drop significantly. Neptune crawls along its path compared to the sprinting Mercury. This is the logic of Kepler and Newton. The farther you are from the mass in the center, the weaker the gravity, and the slower you must move to stay in orbit. Astronomers assumed galaxies would behave the same way. Since most of the visible light, and therefore presumably most of the mass of a galaxy, is concentrated in its bright central bulge, the stars on the sparse outer edges should be moving slowly, lazily drifting through the dark. But when they turned their spectroscopes to the night sky, measuring the Doppler shift of the light from distant stars, they found something impossible. The stars on the outer edges of the galaxies were not slowing down. They were moving just as fast as the stars near the center. In some cases, they were moving even faster. Imagine a merry-go-round spinning in a playground. The children near the center are moving at a manageable speed. But if the outer edge were spinning at the same rate as the center, the children on the rim would be flung off into the grass by the sheer centrifugal force. By all the laws of classical physics, the outer stars of the Milky Way and the stars of every other spiral galaxy we observed should have been ejected into deep space billions of years ago. The galaxies should have dissolved, tearing themselves apart like flywheels, spinning until they shatter. Yet they do not. The galaxies hold their shape. The spiral arms remain coherent, beautiful, and intact. The stars stay locked in their orbits, racing at breakneck speeds of hundreds of kilometers per second, yet never flying away. It was as if an invisible hand was cupping the galaxy, holding the stars in place. It was as if there was a ghost in the machine, a source of gravity that we could not see, touch, or measure with our telescopes. We looked for gas clouds, for dim stars, for black holes, anything that could account for the missing mass. But the visible matter, the normal stuff of the universe, atoms, light, us, was simply not enough. It accounted for perhaps 10 or 15% of the gravity needed to hold the galaxy together. The conclusion was inescapable, and it was humbling. The universe is filled with a substance that is completely invisible to us. We call it dark matter. Dark matter is not just a shadow. It is the scaffold of the cosmos. It does not emit light. It does not reflect light. It does not block light. It passes through the earth, through your house and through your body, as if you were made of mist. It interacts with nothing save for one thing: gravity. We know it is there only because we can see what it does to the things we can see. We see the stars moving too fast, held on a leash by an invisible master. Picture the Milky Way not just as a flat disk of stars, but as being embedded in a gigantic spherical halo of this dark matter. Imagine a glass sphere, vast and transparent, and inside it a flat, glowing snowflake. The snowflake is the galaxy we see, the stars, the gas, the dust. The glass sphere is the dark matter halo. It extends far beyond the visible edge of the galaxy, encompassing it, weighing it down, providing the deep gravitational well in which the stars can race without escaping. This invisible sphere is the reason we exist. Without dark matter, there would be no galaxies. In the early universe, after the Big Bang, the ordinary matter was too hot and too energetic to clump together on its own. It would have remained a diffuse soup of particles. But dark matter, immune to the pressure of light and heat, began to pool together first. It formed the gravitational seeds, the unseen pockets into which the ordinary gas could fall. Dark matter built the cradle, and the stars were the babies that formed inside it. It is the silent, unsung architect of structure. It sculpted the webs of the cosmos, drawing the gas into long filaments, feeding the growth of galaxies, and holding them intact against the centrifugal violence of their own spin. This realization changes how we look at the night sky. When you look up at the Milky Way, that cloudy river of light arching overhead, you are seeing only the tip of the iceberg. You are seeing the glowing foam on top of a deep, dark ocean. The true galaxy is a massive, invisible giant, and the stars are merely glittering decorations clinging to its heart. It is a thought that invites a deep sense of humility. We, made of atoms and light, are the minority. The normal matter that makes up every star, every planet, every book, and every person is just a dusting of snow on the mountain of dark matter. We are the rare, luminous exception in a universe dominated by the unseen. Yet This dark scaffold is not static. It, too, participates in the dance. The dark matter halos are not perfectly smooth. They are lumpy and dynamic. As galaxies drift through the cosmos, they often collide. But these are not collisions of destruction. They are mergers of grace. When two spiral galaxies approach each other, drawn by mutual gravity, they begin a slow, cosmic waltz that can last for billions of years. They do not smash into each other like cars. The distances between stars are so vast that individual stars almost never collide. Instead, the galaxies pass through one another like ghosts, but their gravity tangles. The dark matter halos merge, vibrating and settling into a new, larger shape. The spin of the galaxies is disrupted. The beautiful spiral arms are stretched into long tails of stars, thrown out into the void like streamers. The gases slam together, igniting furious bursts of new star formation. The two spinning disks lose their neat, orderly rotation and become a swarm, a chaotic beehive of motion. Eventually, the chaos subsides. The two galaxies fuse into one massive elliptical galaxy. The orderly spin of the spiral is replaced by the random, buzzing orbits of a swarm. The memory of the original rotation is not lost, but it is scrambled, hidden in the complex trajectories of 1 trillion stars. Our own Milky Way is destined for this fate. In about 4.5 billion years, we will collide with our neighbor, the Andromeda Galaxy. Andromeda is currently rushing toward us at 110 kilometers per second. If you could watch the sky for the next few eons, you would see Andromeda growing larger and larger until it filled the night, a swirling vortex of light. When the merger happens, the night sky will be set ablaze with the birth of new stars. The familiar band of the Milky Way will be torn apart and rearranged. The sun, likely still burning, will be flung into a new orbit, perhaps far out into the halo, where the sky is dark and empty. It will be a magnificent, silent catastrophe, a transformation of spin into a new form of equilibrium. This cosmic violence, however, is played out in extreme slow motion. To a human observer, the sky would look static. A galaxy merger takes eons. The stars move, but they move on timescales that make mountains look like fluid. The universe is dynamic, but its tempo is the tempo of eternity. And so, we see that rotation is the force that balances the dark gravity. The spin of the galaxy prevents it from collapsing into a black hole. It keeps the stars apart, giving them the space they need to nurture planetary systems. It creates the flat, orderly environment where life can have a chance to arise. We are suspended between two great forces, the inward pull of dark matter, trying to crush everything into a point, and the outward push of rotation, trying to fling everything into the void. We live in the delicate boundary between these two, in the stable orbits that exist because the balance is perfect. But what happens when that balance is broken? What happens when gravity wins? What happens when a star runs out of fuel and can no longer support itself against its own weight? In these tragic, violent deaths of stars, we find the most extreme examples of spin in the universe. We find objects that rotate not once a day or once a year, but hundreds of times a second. We find objects so dense that a teaspoon of their matter would weigh 1 billion tons. And we find regions where the spin is so powerful that it does not just move matter, it drags time itself along with it. We leave the majestic, slow-turning galaxies now and zoom in on the graveyards of the giants. We approach the remnants of supernovae, the neutron stars, and the black holes. Here, at the edge of darkness, the laws of physics are stretched to their breaking point, and the gentle spin of the Earth is replaced by a tornado of space-time. Deep within the spiral arms of the galaxy, hidden among the bright tapestries of star-forming clouds, lie the remnants of giants. These are the places where the story of rotation reaches its most dramatic and violent crescendo. We leave behind the gentle clockwork stability of the planets and the slow, majestic drift of the galactic arms. We approach the domain of the extreme, where the laws of physics are stretched until they scream, and where the spin of matter becomes powerful enough to grab hold of time itself and twist it into a knot. To understand these objects, we must first witness a death. Consider a star much more massive than our Sun, a blue supergiant burning with a ferocious intensity. For millions of years, this star has been a balancing act, a sphere of plasma held up against the crushing force of its own gravity by the nuclear fires raging in its core. It is a vast, rotating body, turning on its axis just as the Earth does, though its surface is a roaring ocean of ionized gas millions of kilometers across. But eventually, the fuel runs out. The fire in the engine room dies. In a fraction of a second, the balance is lost. Gravity, which has been waiting patiently for eons, wins the war. The core of the star collapses. We have spoken of the ice skater pulling in her arms to spin faster. Now, imagine that skater is the size of a star, shrinking down to the size of a city in the blink of an eye. The core, once thousands of kilometers wide, is crushed into a sphere no larger than London or Manhattan. The conservation of angular momentum, that ancient law we watched in the solar nebula, asserts itself with terrifying magnitude. The result is a neutron star. It is an object of density beyond human comprehension. A single teaspoon of its material would weigh as much as a mountain, and because it has shrunk so drastically, its rotation has accelerated to a frenzy. The star that once took weeks to turn now spins hundreds of times every single second. Imagine a sphere of solid neutrons, heavier than the Sun, spinning faster than a kitchen blender. The surface moves at a significant fraction of the speed of light. If you were to stand on such a world, an impossibility, given that the gravity would crush you to the thickness of a single atom, you would see the heavens blurring into bands of light. The centrifugal force at the equator is immense, fighting against the crushing gravity, bulging the star into a flattened sphere. These objects are the most precise clocks in the universe. Many neutron stars emit beams of radiation from their magnetic poles like the beams of a lighthouse. As the star spins, these beams sweep across the cosmos. If the Earth happens to lie in the path of the beam, we see a pulse of radio waves every time the star turns. We call these pulsars. When astronomers first detected these regular, rapid pulses in the 1960s, they were so precise that some wondered if they were signals from an alien civilization. But they were simply the song of spin. Some pulsars rotate 700 times a second. If you could convert that frequency into sound, it would not be a rhythm. It would be a hum, a musical note sung by a dying star. These dead suns will continue to spin for millions of years, slowly winding down, solitary tops spinning in the dark, keeping perfect time long after the civilizations that discovered them have faded away. But nature allows for an even deeper collapse. If the dying star is massive enough, even the neutrons cannot hold back the crush of gravity. The collapse does not stop at the size of a city. It continues. The matter falls inward, shrinking past the point of no return, past the event horizon. It vanishes from the visible universe, leaving behind a hole in the fabric of reality. This is a black hole. In the popular imagination, black holes are often thought of as static monsters, gaping maws that simply sit and eat. But in reality, almost all black holes are spinning. They are born from spinning stars, and they inherit that momentum. When the star vanishes, the spin remains. A rotating black hole is perhaps the most exotic object in all of existence. It is not merely a whirlpool of matter, it is a whirlpool of space-time. To understand this, we must visualize space not as an empty void, but as a fabric, or perhaps a viscous fluid, like honey. Albert Einstein taught us that massive objects curve this fabric, creating the gravity that holds our feet to the ground. But in 1918, two physicists, Joseph Lenz and Hans Thirring, realized that Einstein's equations predicted something else. They predicted that a rotating mass would not just curve space, it would drag it. Imagine dipping a spoon into a pot of thick honey and twisting it. The honey near the spoon sticks to the metal and turns with it. The honey a little further out turns more slowly, and the honey at the edge of the pot barely moves at all. This is exactly what a spinning Earth, a spinning neutron star, and a spinning black hole do to the universe. They drag the fabric of space-time around with them. For the Earth, this effect is infinitesimally small. It takes sensitive satellites years to detect the tiny twist we impose on the cosmos. But near a spinning black hole, the effect is catastrophic. The honey of space-time is whipped around at velocities approaching the speed of light. If you were to approach a rotating black hole in a spaceship, intending to hover near it and look down into the abyss, you would find that you could not stay still. Even if you fired your engines with all their might to remain stationary, the space you are occupying is moving. You would be dragged around the black hole, orbiting it whether you wanted to or not. It is like trying to swim upstream in a river that is flowing faster than you can swim. The river carries you, the space carries you. There is a region around a spinning black hole called the ergosphere. It is a place of profound strangeness. The name comes from the Greek word ergon, meaning work, because theoretically one could extract energy from the rotation of the black hole in this zone. In the ergosphere, the space-time is being dragged around so fast, faster than the speed of light, that it is physically impossible to stand still relative to the rest of the universe. To stand still would require you to travel faster than light in the opposite direction, which physics forbids. In this region, you are like a leaf caught in a tornado. But it is not wind that is blowing. It is the geometry of the universe that is flowing. The very definition of forward and backward begins to blur. The spin creates a centrifugal barrier, a force field of twisted space that protects the singularity at the center. And what of time? We know that gravity slows time down. The closer you are to a massive object, the slower your clock ticks compared to someone far away. But spin adds a new dimension to this distortion. The twisting of space twists time as well. In the ergosphere, the future is not a fixed direction in time. It is a direction in space, curving around the black hole. The rotation wraps the timeline of the universe around itself. Recent years have given us the eyes to see these monsters. We have built telescopes the size of the Earth, linking radio dishes from Antarctica to Spain, to capture the silhouette of a black hole against the glowing gas behind it. The image of the supermassive black hole at the center of the galaxy M87, and later the one at the center of our own Milky Way, showed us a ring of fire, An orange donut of superheated gas. That gas is the accretion disk, a vast carousel of matter waiting to be consumed. It is orbiting the black hole at tremendous speeds, driven by the same conservation of angular momentum that shaped the solar system, but here the friction is violent. The gas rubs against itself, heating up to millions of degrees, glowing in X-rays and gamma rays. It is the spin that creates the light. If the matter fell straight in, it might vanish silently. But because it must spiral, because it must shed its rotational energy before it can cross the horizon, it screams with light before it dies. Sometimes the black hole cannot swallow the material fast enough. The magnetic fields, twisted into tight corkscrews by the relentless spin, channel some of the gas away from the horizon. It is blasted outward from the poles in narrow jets. These jets are cosmic blowtorches, streams of particles traveling at nearly the speed of light, shooting out thousands of light years into the void. We see these jets in distant galaxies, piercing the intergalactic darkness. They are the exhaust pipes of the universe's greatest engines. They are powered by the rotation of the black hole itself. The spin of the singularity is being tapped, converted into thrust that can shape the destiny of entire galaxies. A single, rotating black hole can heat the gas of a whole galaxy cluster, preventing new stars from forming, acting as a thermostat for the cosmos. The spin of a dead star can dictate the life of 1 trillion future suns. It is humbling to think that the same principle that makes a child's top wobble on a table is the same principle that powers these quasars, the brightest beacons in the universe. The scale is different, but the law is the same. Rotation is the great equalizer, the common language of all matter. As we linger here at the edge of the event horizon, contemplating the warping of reality, we might ask ourselves, what is inside? If we could survive the journey, if we could cross the veil of the horizon without being torn apart, what would we find? Classical physics tells us we would find a singularity, a point of infinite density where space and time end. But because the black hole is spinning, the mathematics suggests something different. A spinning singularity cannot be a point. It must be a ring of zero thickness but finite radius, suspended in the dark heart of the whole. Some theories, wild, unproven, but beautiful, suggest that this ring might be a gateway. Because the ring spins, the centrifugal force might counteract the gravity at its very center. If one could pass through the ring without touching it, one might avoid being crushed. Where would one go? To another region of space? To another time? To a universe born from the back of our own? We do not know. The equations break down. The spin leads us to the edge of knowledge and points into the unknown. But we do not need to enter the black hole to feel its influence. The gravitational waves, ripples in the fabric of space-time that wash over the Earth, are often the result of black holes merging. When two of these spinning giants spiral into each other, they shake the universe like a bell. The LIGO observatories have heard these chirps, the sound of two event horizons kissing and becoming one. In that final fraction of a second, more energy is released than by all the stars in the visible universe combined. And it is all rotational energy, released in a final, cataclysmic shudder. This, then, is the ultimate expression of the why of spinning. Why does the universe spin? Because it must conserve its energy. It spins to fight against the dark. It spins to structure the void. In the case of the black hole, it spins to preserve the memory of the star that once was. The star is gone. Its light is extinguished. Its matter is crushed. but its angular momentum remains. The ghost of the star's rotation continues to twist the universe, an immortal testament to the motion that created it. We have traveled from the gentle spin of the Earth, which gives us our days, to the terrifying spin of the black hole, which bends our time. We have seen that rotation is the ruler of the macroscopic world. It governs the planets, the stars, and the galaxies. It creates stability, and it creates chaos. But the story of spin is not just written in the gargantuan structures of the heavens. It is also written in the invisible ink of the microscopic. If we turn our gaze away from the horizon of the black hole and look down into the very atoms that make up our bodies, we find that the mystery of rotation goes deeper than we ever imagined. We are not just living on a spinning world. We are made of spinning things. The stability of the chair you sit on, the light of the lamp beside you, the magnetism of the earth that guides the compass, all of these arise from a different kind of rotation. A rotation that is not a movement of matter, but a fundamental property of existence. Let us descend now from the scale of the light years to the scale of the femtometers. Let us journey into the quantum realm, where we will discover the heartbeat of matter itself. We have witnessed the rotation of the largest structures in existence, from the majestic, slow-turning arms of spiral galaxies to the violent, time-warping vortices of black holes. We have seen how gravity and angular momentum work together to sculpt the heavens, creating a cosmos of circles, ellipses, and spirals. But now we must leave the realm of the gargantuan. We must turn our gaze away from the telescope and look instead through the microscope, zooming in past the limits of human vision, past the cellular structures of biology, and into the fundamental building blocks of reality itself. Here, in the subatomic world, the story of spin takes on a profound and mysterious quality. It ceases to be merely a description of motion and becomes a description of identity. Imagine, if you will, looking at your own hand. It appears solid, motionless, and stable. But if we could descend into the skin, through the tissues and the blood vessels, into the molecules of protein and water, and finally into the atoms themselves, we would find that there is no stillness here. The atom is not a static brick. It is a hive of ceaseless activity. For decades, the popular image of the atom was that of a miniature solar system. We pictured the nucleus, a cluster of protons and neutrons, sitting in the center like a tiny sun, while electrons whizzed around it in neat circular orbits like little planets. It is a beautiful, comforting image, suggesting that the laws of the macrocosm are mirrored perfectly in the microcosm. But as physicists peered deeper into the 20th century, they discovered that this picture was a mirage. The quantum world does not behave like the world of rocks and planets. An electron does not orbit the nucleus in a smooth, predictable path. Instead, it exists in a state of probability. A shimmering cloud of potential. It is here, and it is there, and it is everywhere at once, forming a shell of energy around the core. Yet, despite this ghostly ambiguity, these particles possess a property that seems to anchor them to the physical world. They spin. Physicists call this intrinsic angular momentum, but the word spin is the shorthand that has stuck. However, we must be careful with our imagination here. When we say an electron spins, it is not quite the same as a basketball spinning on a finger, or the Earth rotating on its axis. If an electron were a physical ball spinning fast enough to generate its measured magnetic field, its surface would have to be moving faster than the speed of light, a violation of the laws of physics. So, what is it doing? In the strange language of quantum mechanics, the electron simply has spin. It is not something the electron does, it is something the electron is. Just as it has mass and electric charge, it has spin. It is a fundamental label, a tag attached to the particle by the universe at the moment of its creation. It is a built-in vibration, a permanent twirl that can never be stopped, never be slowed down, and never be removed. This intrinsic spin is the quantum heartbeat of matter. Even at absolute zero, the coldest temperature theoretically possible, where all thermal motion should cease, the spin remains. It is the unquenchable spark of motion that lies at the bottom of everything. But why does this matter? Why should we care about the abstract mathematical rotation of a particle so small it cannot be seen? We should care because this ghostly spin is the reason the universe has structure. It is the reason you are not falling through your chair right now. It is the reason the ground is solid beneath your feet. This leads us to one of the most elegant and important rules in all of nature, the Pauli exclusion principle. Named after the Austrian physicist Wolfgang Pauli, this law is governed entirely by spin. It states, in simple terms, that two electrons cannot occupy the same quantum state at the same time. They are like stubborn dancers who refuse to stand on the same spot on the floor. If electrons did not spin, or if they spun in a different way, this rule would not exist. Without the exclusion principle, the electrons in an atom would all collapse into the lowest possible energy level, crowding tight against the nucleus. Atoms would lose their volume. They would shrink to almost nothing. There would be no chemistry. There would be no bonds between atoms to form molecules. There would be no water, no rock, no DNA, and certainly no stars. The universe would be a dense, dull soup of compact matter. But because electrons spin, they resist one another. They demand space. They stack up in layers, forming the electron shells that give atoms their size and their ability to interact with one another. When you touch a wall, your hand does not pass through it because the spinning electrons in your skin are being repelled by the spinning electrons in the wall. The sensation of solidity, of touch, is actually a force field generated by the geometry of quantum spin. The universe feels real to us because its fundamental particles refuse to share their space. This resistance is so powerful that it can hold up stars. When a sun-like star dies and collapses into a white dwarf, it is the pressure of these electrons, pushing against each other, protecting their quantum turf, that stops the star from crushing itself completely. The corpse of the star glows white-hot, held stable for billions of years solely by the stubbornness of spin. Spin is also the architect of magnetism. We have all played with magnets, feeling that invisible rubbery resistance when we try to push two like poles together. That force is a macroscopic manifestation of microscopic spin. Inside a piece of iron, the electrons are acting like tiny compass needles. Because they are charged particles and they are spinning, they generate a minuscule magnetic field. In most materials, these spins are jumbled, pointing in random directions, canceling each other out. But in a magnet, the spins align. Billions upon billions of electrons agree to dance in unison, pointing their axes in the same direction. The tiny, individual fields sum up to create a force strong enough to lift a car or guide a compass needle toward the north. When we look at the Earth's magnetic field, the giant shield that protects our atmosphere from the solar wind, We are looking at the result of a spin on a grand scale. Deep in the planet's core, molten iron churns and rotates. The alignment of the spins in that liquid metal generates the magnetosphere. It is a chain reaction. The spin of the electron creates the magnetic field. The spin of the Earth organizes it, and the result is a habitable planet. But the electron is not the only dancer on this stage. Every particle in the standard model of physics has a spin. The protons and neutrons in the nucleus spin. The quarks that make up the proton spin. Even the ghost-like neutrinos, which pass through the Earth by the trillions every second, possess this property. And then there are the particles of light, the photons. Light, too, spins. We do not often think of sunshine as rotating, but it is. A photon carries a spin of 1, while an electron carries a spin of 1/2. This integer difference separates the universe into two great families, the fermions and the bosons. The fermions, the electrons, protons, and neutrons, are the matter particles. They are the solitary ones, the ones that obey the exclusion principle and build solid structures. They are the bricks of the cosmos. The bosons, like photons, are the force carriers. They are the social particles. They do not mind sharing space. You can pack billions of photons into a single laser beam, all marching in perfect step, occupying the same state. This difference in behavior, this fundamental division between stuff and light, is determined entirely by the value of their spin. It is a realization that borders on the philosophical. The difference between a rock and a ray of light comes down to the rhythm of their rotation. The architecture of reality is built on the mathematics of a pirouette. As we delve deeper into this quantum realm, we find that spin is used by life itself. In the quiet, sterile rooms of hospitals, we use the spin of protons to look inside the human body. Magnetic resonance imaging, or MRI, is a machine designed to talk to the spin of atoms. The human body is mostly water, and every water molecule contains hydrogen atoms. The nucleus of a hydrogen atom is a single proton, and that proton spins. When a patient lies inside the massive magnet of an MRI scanner, the intense magnetic field forces the spins of these billions of hydrogen protons to align, like soldiers snapping to attention. The machine then sends a pulse of radio waves, knocking the protons out of alignment, making them wobble like dying, spinning tops. As they wobble and struggle to realign with the field, they emit a signal, a tiny radio whisper. The machine listens to these whispers. Because protons in bone, fat, and water relax at different speeds, the computer can build a detailed image of the interior of the body. We are using the fundamental angular momentum of the universe to heal ourselves. We are listening to the song of the proton to find the broken places within. Even in the chaotic, warm environment of biology, spin may play a role. There is a growing field of quantum biology that suggests birds might use the quantum spin of electrons in their eyes to see the Earth's magnetic field, allowing them to navigate across thousands of kilometers during migration. The robin, flying through the night, may be guided by the delicate, entangled spins of particles reacting to the planet's poles. Life, it seems, has learned to hitch a ride on the fundamental motion of the cosmos. There is something deeply reassuring about the permanence of this motion. In the previous chapters of our journey, we spoke of things winding down. We spoke of tides slowing the Earth, of friction slowing galaxies, of black holes evaporating. In the macroscopic world, entropy eventually claims everything. Motion decays into heat, and heat diffuses into nothingness. But in the quantum world, the spin does not decay. An electron created at the dawn of time, 13.8 billion years ago, is still spinning today with exactly the same magnitude. It has not slowed down by a fraction. It has not lost energy to friction, for there is no friction in the vacuum of the quantum state. It is a perpetual motion machine, a little engine that runs forever. This means that the fundamental nature of the universe is not static. We often think of peace or rest as a lack of motion. We imagine that if we could stop everything, we would achieve perfect tranquility. But the universe disagrees. At its very core, reality is dynamic. To be is to move. To exist is to spin. The bedrock of our reality is not a frozen foundation. It is a vibrating, oscillating, rotating sea of energy. The stillness we perceive with our eyes is an emergent property, a balance achieved by the cancellation of trillions of tiny motions. It is like the stillness of a hummingbird hovering in the air. It looks motionless, but it is sustained by a blur of activity. As you lie in the dark, breathing slowly, consider the atoms that make up your breath. The oxygen you inhale is not dead matter. It is a collection of spinning nuclei surrounded by spinning clouds of electrons. Every breath is the intake of billions of tiny gyroscopes. They enter your blood, binding to the iron in your hemoglobin, iron that is magnetic because of its spin, and they travel to your cells to fuel the fire of your life. You are a symphony of spins, from the DNA in your cells to the calcium in your bones. You are constructed from motion, and you are connected to the furthest reaches of the cosmos by this shared property. The electron in the tip of your finger obeys the exact same laws of spin as the electron swirling in the accretion disk of a black hole a billion light-years away. There is no here and there when it comes to the laws of physics. There is only one great tapestry, woven from the same threads, twisting with the same torque. This quantum spin is the bridge between the material and the immaterial. It is a property that defies our classical intuition, a rotation without a rotating surface, a motion that requires no energy to maintain. It hints that the universe, at its deepest level, is more like a thought or a musical note than a machine. It is a vibration. It is a quality. And so, we find that the why of the spinning universe has a different answer in the quantum realm. Why does the electron spin? Because if it didn't, it wouldn't be an electron. The spin is the definition. The universe spins because it is the only way for it to be something rather than nothing. We have now traversed the entire scale of reality. We have seen the birth of the planets in the dusty nebula. We have felt the dark matter holding the galaxies together. We have touched the edge of the black hole where time twists, and we have shrunk down to the atom to find the eternal heartbeat of the fermion. All of these motions, the orbital, the galactic, the relativistic, and the quantum, are happening simultaneously, right now, in the silence of your room. But what of the future? We know the electron's spin is eternal, but what of the great rotations of the stars and the worlds? We know that the moon is drifting away. We know that the stars are burning out. Is the universe destined to stop turning? Will the great dance eventually come to a halt, leaving only the ghostly, solitary spin of the particles in the dark? To answer this, we must cast our minds forward. We must accelerate the clock, speeding through the eons, watching the galaxies age and the stars die, to gaze upon the final epic of the universe. We must look toward the slow drift into eternal silence. Let us cast our minds forward now, beyond the familiar cycles of our days and years, and project our imagination into the deep future. We have traveled back to the fiery birth of the cosmos, and we have explored the vibrant, spinning present. But the story of the universe is, ultimately, a story of evolution. It is a narrative that flows in one direction, from the hot and dense to the cold and diffuse, from the energetic to the quiet. Time is the great leveler. It smooths the mountains, dries the seas, and slowly, imperceptibly, applies the brakes to the great celestial engines. The universe we see tonight, the universe of blazing spiral galaxies and frantic pulsars, is not a permanent state. It is merely a phase, a brief, glittering firework display in a timeline that stretches into eternity. We are living in the stelliferous era, the age of stars, the age of spin. But this age will not last forever. The first signs of this long winding down are happening right here in the silence of our own room. As we drift toward sleep, the moon is drifting away from us. It is a retreat measured in millimeters, about 3.8 centimeters every year, roughly the speed at which human fingernails grow. This seems insignificant, a trivial shift in the cosmic dance. But given enough time, these millimeters add up to thousands of kilometers. The cause is the tide. As the Earth spins beneath the moon, the gravity of our satellite drags the oceans across the planet's surface. This friction acts like a giant liquid brake pad. The energy of the Earth's rotation is being stolen, transferred outward to the moon, pushing it into a higher, slower orbit. The consequence is that our day is lengthening. Hundreds of millions of years ago, a day on Earth was less than 22 hours long. Dinosaurs saw the sun rise and set at a quicker tempo than we do. In the distant future, the day will stretch to 25 hours, then 30, then 40. The rotation of our home is slowing down, surrendering to the relentless tug of gravity. If the Earth and Moon were left alone forever, surviving the eventual death of the sun, they would eventually reach a state of perfect stillness relative to one another. The Earth would slow until it rotates only once for every orbit of the Moon. The day would be as long as the month, lasting hundreds of our current hours. In this distant future, the Moon would hang fixed in the sky, visible only from one hemisphere of the Earth, a permanent sentinel over a frozen ocean. The tides would cease. The great sloshing of the world's waters would fall silent. The dynamic relationship between the two bodies would settle into a locked, eternal embrace. This phenomenon, known as tidal locking, is the destiny of all orbiting bodies. We already see it in the worlds around us. The Moon is already locked to the Earth, showing us only one face. Pluto and its moon, Charon, are locked to each other, spinning face to face like dancers, holding hands. It is the universe's way of finding equilibrium, of ironing out the differences in motion until peace is achieved. But this local silencing is just a microcosm of what awaits the galaxy. The Milky Way, currently a factory of star formation, is running out of raw materials. The great clouds of hydrogen are being consumed, turned into stars, and then trapped in the dense cores of white dwarfs and neutron stars. The recycling efficiency of the cosmos is not perfect. With every generation of stars, more matter is locked away in dead remnants, unable to spin up into new suns. In a few trillion years, the last red dwarf stars will flicker and die. The lights of the galaxy will go out, one by one, until the sky is black. What remains will be a graveyard of stellar corpses, black holes, neutron stars, and cooling white dwarfs drifting through the dark. These remnants will still be spinning. The conservation of angular momentum ensures that they keep their rotation for eons, but they are not immortal. Even in the vacuum of space, they are not truly isolated. They interact with the interstellar medium, with dark matter, and with each other. Imagine a neutron star, that city-sized flywheel we visited earlier, spinning in the deep future. As it rotates, its immense magnetic field plows through the thin plasma of space. This creates drag, a subtle resistance that saps the star's energy. The spin slows, the pulses become less frequent. The lighthouse beam grows dimmer and sweeps slower until eventually the radio song fades into static. The star becomes a dark, silent sphere of iron and neutrons floating unrecognized in the void. Even the black holes, the great hoarders of spin, must eventually pay their debt to entropy. According to the theories of Stephen Hawking, black holes are not truly black. They emit a faint, ghostly radiation. This radiation carries away mass and energy. Over timescales that defy human comprehension, years numbered with a 1 followed by nearly 100 zeros, the black holes will evaporate. As they shrink, they spin faster, just as the nebula did at the beginning of time. But this is the final flourish. When a black hole finally vanishes, popping out of existence in a burst of gamma rays, its angular momentum is released. The spin that was once trapped in the singularity is returned to the universe, scattered into a bath of photons and particles. This leads us to the concept of the heat death of the universe, a term that sounds frightening, but is actually a description of perfect calm. It is a state where energy is evenly distributed, where temperature differences are smoothed out, and where macroscopic motion ceases. In this distant era, the galaxies will have dispersed. The expansion of the universe will have pulled them so far apart that they are no longer visible to each other. The stars will be cold ash. The black holes will be gone. The universe will be a vast, expanding sea of subatomic particles and long-wavelength radiation. Will the spinning stop then? In the macroscopic sense, yes. The great wheels of the galaxies will no longer turn because there will be no galaxies. The planets will no longer orbit because the stars they circled have dissolved. The concept of a day or a year will lose all meaning, for there will be no rising suns to mark the passage of time. The grand clockwork mechanism will have unwound. But remember the lesson of the quantum world. Remember the electron. Even in this ultimate frozen winter of the cosmos, the fundamental particles will still be there. An electron drifting through the void, a trillion years from now, will still carry its intrinsic spin. It will still possess that fundamental angular momentum of 1/2. A photon traveling through the endless dark will still rotate with a spin of 1. The motion of the universe will have retreated from the scale of the visible to the scale of the invisible. The structure will be gone, the drama will be over, but the essence of reality, the dynamic vibration of existence, will remain. The universe does not end in a dead halt. It ends in a hum, a whisper of quantum potential that persists forever. This realization brings us back, gently, to the present moment. It brings us back to the here and now, to the warmth of your bed, to the rhythm of your breathing, and to the knowledge that we are living in the golden age of the universe. We are privileged observers. We have awakened in the brief, beautiful epoch between the violent fire of the Big Bang and the long, cold silence of the end. We are alive in the time of the spin. We are here while the galaxies are still bright, while the planets are still turning, and while the moons still pull the tides. The motion that we feel, or rather, the motion that we are part of, is a gift. It is the source of all change, all energy, and all life. The rotation of the Earth gives us the cycle of waking and sleeping, a rhythm that is mirrored in the beating of our hearts and the firing of our neurons. The orbit of the Earth gives us the seasons, the planting and the harvest, the migration of birds, and the blooming of flowers. It is easy to feel small when confronted with the vastness of these cosmic mechanics. It is easy to feel insignificant when we realize we are clinging to a rock, spinning at 1,600 kilometers per hour, orbiting a nuclear fireball, drifting through a dark matter halo. But science tells us that we are not separate from this machinery. We are not passengers. We are the machine itself observing its own operation. The angular momentum that shaped the solar system is the same angular momentum that keeps your atoms from collapsing. The gravity that guides the Milky Way is the same gravity that holds you to your mattress. The carbon in your body was forged in a spinning star. The iron in your blood was concentrated in a spinning core. You are a child of the rotation as you settle into the stillness of the night. Let this knowledge wrap around you like a blanket. You do not need to hold on. The universe has been holding you for 13.8 billion years. The forces that keep the stars in their courses are the same forces that keep you safe. The spinning of the world is not a chaotic ride. It is a cradle. It is a rocking motion, gentle and constant, that has lulled life to sleep for eons. The earth turns so that the sunlight can nourish the plants on the other side of the world. It turns so that the winds can circulate and the rains can fall. It turns to bring you the night, the darkness that allows your body to rest and repair. Tomorrow morning, the horizon will dip down again, revealing the sun. The illusion of the sunrise is actually the reality of your own movement, the planet rolling you forward to meet the light. But for now, you are on the dark side of the sphere. You are in the shadow of the world, protected from the glare, held in the quiet, velvet pocket of the night. Everything is moving: the room, the house, the city, the continent. The air you breathe is swirling. The blood in your veins is circulating. The atoms in your brain are vibrating. And yet, amidst all this motion, there is a center of calm. There is a point of balance. That point is you. You are the observer at the center of the storm. The universe spins around you, complex and magnificent. But here in this moment, you can simply be. You can let go of the need to control, the need to understand, the need to move. You can entrust yourself to the momentum of the earth. It has never dropped you. It has never stopped turning. It will carry you through the darkness and deliver you safely to the dawn. Close your eyes now. Feel the gravity that anchors you. Feel the solidity of the spinning world supporting you. Listen to the silence, which is not an absence of sound, but the harmony of a billion perfectly balanced forces. The stars are turning overhead. The galaxy is drifting through the void. The particles within you are dancing their eternal quantum dance, and you, a conscious spark of this great rotating cosmos, are free to rest. Drift away on the great silent ship of the earth. The journey is smooth, the path is sure, and the universe is turning, softly and endlessly in the dark.